Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on radioactivity from October-November 2021, Paper 2, Variant 1. This is a typical type of question because you will see this type of questions very often in past papers. For part A, we need to complete table 6.1 to show the masses in terms of atomic mass unit U and charges in terms of elementary charge E of alpha, beta plus and beta minus particles. First of all, let's try to understand these particles. Alpha particle, first of all, simply this is helium nucleus. So we can write down alpha particle is equal to helium nucleus. So as it is helium nucleus, it means it has no electrons. So helium nucleus is very important. Sometimes in exam, they will ask you what is alpha particle. So simply you can say is helium nucleus. And the symbol for alpha particle is alpha, and this is atomic number of this one is 2 and the mass number of this one is 4. In some books, you will also see this symbol for alpha particle. Now we need to understand alpha particle, its atomic number is 2. So it means that the number of protons it has, that is equal to 2. Mean it has simply 2 protons and it has 2 neutrons. We can say number of neutrons. So alpha particle consists of 2 protons and 2 neutrons. Now we need to understand what is the charge on alpha particle, and charge on alpha particle is equal to the charge on 2 protons. Protons and electrons, they have the same charge but their sign is opposite. So simply we can say the charge on alpha particle is plus 2e. And next question is asking us about the mass of alpha particle. Alpha particle consists of 2 neutrons and 2 protons. Mass of proton is about equal to the mass of neutron, and the mass of proton or mass of neutron is almost equal to 1u. So simply we can say as it consists of 2 protons, 2 neutrons, so the mass of alpha particle is equal to 4u. That's all what we need to write down for alpha particle. So simply we can write down 4 here because unit is already given and the charge on alpha particle is plus 2. That's all what we need to write down. Let's move on to beta particle. Beta particle, in fact, this is electron. So simply we can write down beta particle is electron, and the mass of electron is this one. So this is mass of electron, and the charge on electron is simply this is minus 1e. So this is charge on electron. Next one is beta plus particle. Beta plus particle, in fact, this is antiparticle of electron. So simply we can write down here this is antiparticle of electron. Antiparticle of electron, we also call this one, this is positron. So beta plus particle also we call this is positron. So as this is antiparticle, so the mass of beta plus is the same as mass of electron. So we can say the mass of beta plus particle is the same as mass of electron. So this is 9.11 times 10 to negative 31 kgs. But this is antiparticle, so the charge on this one is opposite to electron. So it has plus 1e charge, mean it has opposite charge. So this is what we need to understand about beta plus and beta minus particle. For example, charge on beta plus is simply plus 1e and the charge on electron is minus 1. So simply we can write down here. Now we need to write down this mass in terms of u. So the mass we have in kgs and 1u is also given. This is given in data actually. You can check this one in data table. So now we need to convert kgs into u. So simply we can write down mass in kgs divided by mass in u, means 1u is equal to how many kgs, and 1u is equal to 1.66 times 10 to negative 27 kgs per u. So if you do this division, your final answer will be 0.005 u, because you can see kg cancel, so we got u. So the mass of beta plus particle is simply 0.005 0.005. Mass of beta minus particle is also the same because they're particle and antiparticle. And that's all what we need to write down. If you write down all these right, you will get 4 marks. So this question has 4 marks. For part B, it is given to us carbon-14 is radioactive and decays by emission of beta minus particles. Nuclei do not contain beta minus particles. It simply means that there is no electron in the nucleus. We need to explain the origin of beta minus particle that is emitted from the nucleus during beta minus decay. So this question is simply about beta minus decay. If we understand what is beta minus decay, then we can answer this question. So let's try to understand first of all what is beta minus decay. Let's say we have nucleus X, it has atomic number Z and it has mass number A. It decays by beta minus decay. So it will form another nucleus. It will also emit beta minus particle and also one electron neutrino, electron anti-neutrino, because this is particle, so this has to be antiparticle to conserve lepton number. Now from here you can simply understand. So the atomic number of this new nucleus, this has to be Z plus 1 and its mass number will stay same. Now if you look at this one, you can see the proton number increases by 1. So it simply means that one neutron it becomes proton, and also there is one beta minus particle, or simply you can say this is electron. So that's the reason one neutron changes to proton and also it emits one electron. So that's the reason when this nucleus, this decays into nucleus Y, beta minus particle is emitted because neutron decays into proton and electron. So simply here we can write down neutron decays into proton and electron, decays into proton and electron. So simply this is what you need to write down, into proton and an electron. So that's the reason when this nucleus will decay, it will emit beta minus particle, mean electron will be emitted. And this question has only 1 mark, B mark. If you write down this one, you will get this mark. For the second part, we need to state the change in the quark composition of carbon-14 nucleus when it emits beta minus particle. But we have already discussed in beta minus decay, neutron decays into proton. Simply we can write down neutron decays into proton. Neutron consists of one up quark and it consists of 2 down quarks. Proton, it consists of 2 up quarks and 1 down quark. So simply from here we can see that 1 down quark it decays into 1 up quark. So for this question simply you can write down 1 down quark decays into up quark. So if you write down this one, you will get 1 mark and that is B mark. Simply you have to write down this. For the last part, question is asking us to suggest why the beta minus particles are emitted with a range of different energies. Let's try to understand this one with the help of nuclear decay, means beta minus decay. Let's say we have nucleus X, it decays into nucleus Y by emitting beta minus particle and electron anti-neutrino. Atomic number of this nucleus will be Z plus 1 because this is beta minus decay, and the mass number of this one will be A. Now our main focus has to be on these 2 particles. In order to understand why the beta minus particle, it has a range of energies. Let's say the total energy of these 2 particles, I will simply write down here. Let's say the total energy of these 2 particles is 100 mega electron volt in one nuclear reaction, or in one nuclear decay, or simply we can say in this nuclear decay. So the energy of this beta minus particle, this can be 40 mega electron volt. If the energy of this one is 40 mega electron volt, so the energy of electron anti-neutrino, this one will be 60 mega electron volt. If the energy of this electron anti-neutrino is 70 mega electron volt, then the energy of this one will be 30 mega electron volt. If the energy of this one is 80 mega electron volt, let's say this is 80, so the energy of beta minus particle, this will be 20 mega electron volt. So it's simply, this is telling us is that the energy is shared between these two particles. Energy of electron antineutrino is more than the 50% most of the time, and the energy of beta minus particle will be less than 50% of the total energy of these particles. Now let me explain to you how you can write down answer for this question. So this is how you can write down the answer. In this answer, you can see I have mentioned electrons, neutrinos are immediate. If you write down this 1 point, you will get 1 mark, and this is B mark. Mean it has to be in your answer. And the second mark you will get if you have mentioned energy released in decay is shared between anti-neutrino and beta minus particle, means energy is shared between these two particles. So that's reason this beta minus particle or this electron anti-neutrino, they have a range of energies. And this was also the reason behind discovery of neutrinos. So this was the reason behind discovery of neutrinos, because when scientists they did different experiments, they found out this beta particle, it has a range of energy. So then they started to look for another particle that has the missing energy, and then finally we found out there is another particle, and that particle was named neutrino because neutrino has no charge.